Okay, for review. Number 1, find the average and SD of the list 41, 80, 50, 50, 54, and 57. I have those numbers in my calculator, and I push Stat, go over to Calc, and do one variable statistics. And I get X bar equals 50, and my standard deviation is 5. Which numbers on the list are within 0.5 SDs of the average? What does it mean to be within 0.5 SDs of the average? So which numbers in that list right there are within half of this, which is 2.5? So is 41 within 2.5? Nope. 48? Yes. 50? Yes. 50? Yes. And the other two are no. Okay. Which ones are within 1.5 SDs? How big is 1.5 SDs? Well, it would be this times 1.5, which is 7.5. And now we have to include which ones? Is 41 within 2.5 or 1.5? Grab that. 41 is not. What about 54? Yes. And 57? Yes. So it turns out it worked. Okay. I think it's over here. It's right there. All right. Oh, look what I did. Number 3. Here is a list of numbers. Without doing any arithmetic, guess whether the average is around 1, 5, or 10. Just by looking at it, could it be 1? Probably not. Why? There are only a couple numbers less than 1. Could it be 10? No, why not? None of the numbers are bigger than 10, so it's probably 5. Without doing any arithmetic, guess whether the SD is 1, 3, or 6. Could it be 6? No. Why not? 68% of the numbers are supposed to be within 1 SD. So if I take my average of 5 and I add 6, I get 11. And if I subtract 6, I get negative 1. Are 68% of the numbers between negative 1 and 12? All of them are within that far, right? So let's try 1. So 5 plus 1 is 6, and 5 minus 1 is 4. Are 2/3 of the entries between 4 and 6? How many of them are between 4 and 6? 1, 2, 3, 4. I only saw 3. But anyway, are 2/3 of them within 4 and 6? No. So let's try 3. 5 plus 3 is 8. 5 minus 3 is 2. Is it reasonable to think that 2/3 of the numbers are between 2 and 8? Yeah, if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 out of, what is it, 20? 12 out of 20 is pretty close to 2/3. All right, number 6. Below are sketches of histograms for 3 lists. In scrambled order, the averages are 40, 50, and 60. Which one has an average of 40? 3 and 50 2, and 60 would be 1. Okay. Match the histogram with the description. The median is less than average. So let me draw these so I can draw the marks. Okay. So obviously this one has the median and the average being exactly the same place. What does median do on a histogram? What does the median tell me about the histogram? It's when the areas match. So this right here splits the two areas, maybe just slightly to the right. That splits the two areas into equal sizes. What does the mean measure? It's the middle of the weight. Okay? And over here we have lots of people that don't weigh very much on the left side. What does that do to the mean? It pulls it. So this is median and this is the mean. A left-tailed graph pulls the average to the left because the people on the left don't weigh very much, and that messes with the average. Okay, and then the opposite happens over here. If this is my median, well, maybe not there, but if that's my median, the area to the left and the area to the right are the same size, but these people over here weigh a lot, and because they weigh a lot, they pull the average to the right. Does that make sense? And we call this a right-tailed graph, and we call this a left-tailed graph, because that the tail of heavy or very light people is in that direction. C, is the SD of histogram 3 around 5, 15, or 50? So histogram 3, what am I looking for? How do I calculate SD from a graph? You look for 2/3 of the people. So this is my graph, and then this is my X bar. I want to grab 1/3 of the people over here and 1/3 of the people over here. So each one of those equals 1/3, and then I look at how far is that? Well, is 50 going to work? No, 50 is way too big. Is 5 going to work? No, that's too small, so it's probably about 15. True or false? The SD for 1 is a lot smaller than the SD for 3. False. Why? They're going to be exactly the same. How come? They have the same spread. The graph is exactly the same shape. It's just been flipped. Does the SD care whether your highs and your lows have been switched? Why not? Because you're going to square it, right? You're going to find the distances, and some of them will be negative and some of them will be positive, and you square it, and that goes away. And when you look at a graph that's a mirror image, then your old negatives are your new positives, and when you square all those, you eliminate the negatives also. And 7. A study on college students found that men had an average height of 66 kilograms with an SD of 9. The women had an average weight of 55 kilograms with an SD of 9. Find the averages and SDs in pounds. So we just multiply by 2.2. So 66 times 2.2. So the X bar for men, no. So 66 times 2.2 is 145.2. What do you get for the SD of men? 19.8. And my X bar for females is 121. And my SD for females is going to be the same, 19.8. Okay. Just roughly, what percentage of men weighed between 57 and 75? So this is in kilograms, 66, 75, and 57. How many people fit in that group? 68%. How come? Because this is plus 9 and this is minus 9. Right? Okay. If you took the men and women together, would the SD of the weights be smaller than 9, just about 9, or bigger than 9? This is a great question. So the men and the women have the same spread. So here are the women. And then the men, how does the male curve differ from the female curve? It's just slid to the right. How far? 9. Okay. If I added all of those people together, is it more spread out, less spread out, or the same spread out as the original two graphs? Well, my new curve would look like this. Right? And maybe I have those, maybe it should be more like that. Is that red graph more spread out or less spread out than the original? More. Why is that? Does everybody understand that? This is a really good thing to know. Do you see how it's more spread out? Okay. So let's say my weights were, for women, 42, 44, 49, 50, 56, 60, and 68. Okay? Those are my women. I'm just making it up. It probably isn't accurate, but whatever. How do the men compare to the women? They are 9 kilograms heavier. So I would get 51, 53, 58, 59, 65, 66, and 69 and 75, right? The SD for this list, 7. Wow, that was way off. The SD for this list is 9. The SD for this list is 9. But what happens when I put the two groups together? Well, my maximum spread here is 26 kilograms. And my spread here is also 26 kilograms. But when I combine them all together, now my spread goes from 42 all the way up to 77. Does that make sense? So this group has a spread of 9, and this group has a spread of 9, about 9 on average. But now I calculate a new average. This average was 55, and this average was 66. The average between them is going to be 50, about 50, right? And how far is that from 50? And how far is that from 50? That's going to make everything much more spread out. Does that make sense? All right.